Welcome to Pre-Calc 2. In this course, we're actually going to spend probably around 2/3 of our time just focusing on trigonometric functions. Okay. And if you don't know what those are, you will hear by the end of the week. Okay. But trigonometric functions are used all over the place. Anything that oscillates really is typically going to be described by a trig function. But before we can do that, we need to start from scratch. We need to start at angles here. We need to start building up some definitions and some framework so that we can actually talk about these new functions. Okay. And it ends up that we use a lot of Greek letters in math and science. Okay. And in this class specifically, we'll be using the Greek letters alpha, beta, gamma, theta, and phi quite a bit to represent angles. Okay, and let's see what those look like. So alpha kind of looks like a fish. Beta kind of looks like a bee. Gamma, theta, and phi. All right, and let's move on to our first definition. Okay, so the measure of an angle is a measurement between two intersection lines, line segments, or rays starting at the initial side, so not a very creative name, and ending at the terminal side. Okay, so we actually have three definitions here, really. And I'll probably add a fourth here in a minute. Let's sketch our angle in here, though. So let's just suppose that our angle is traveling in this direction. Okay, we'll call it theta. So there's our angle. Well, if we're traveling in this direction, then this must be the initial side, and the other one must be the terminal side. All right, and I could actually add on one more definition here, and we're going to do that right here, where these two rays are, where these two rays start. This is our vertex. Okay. And one thing about the measure of an angle is we are really measuring rotation here. Okay, really measuring rotation. All right, on to number 2 here. An angle is in standard position if the vertex lies at the origin, 0, 0, and the initial side lies along the not just x-axis, but positive x-axis. Okay, and actually, most of the time when we're thinking about our trig functions this quarter, we'll oftentimes be thinking about angles in standard position. Okay, so this won't actually be that unusual. Okay. To finish off this sketch here, though, if I want to make sure that this picture, that the initial side is actually on the positive x-axis, I need to indicate what direction we were traveling. Okay. So now I can see, yeah, this one over here, this is our terminal side, and this one is our initial side. Okay. And why don't we go ahead and name this angle alpha. Okay. All right, so in 3 and 4 here, we're going to be talking about the sine of an angle. Okay. And so we can have positive and negative angles. And the way that we've chosen to define our positive and negative angles is positive angles are generated by counterclockwise rotation. Okay, so this means a lot of the angles that we're going to be talking about, their initial side is going to be on the positive x-axis, vertex at the center, and oftentimes we're going to be rotating counterclockwise. Okay. That's not to say that we won't have some negative angles. We definitely will. And so negative angles, this is when we rotate clockwise. All right, and if you wanted it to actually still be in standard position, we could write this little red arrow here in a different spot. We want this to actually be an angle that is in standard position. We just need to do this. Okay. And why don't we call this one alpha and this one beta? All right, so on to some more terminology here with number 5. Okay. In number 5 here, we're just learning how to describe the location of our angles. Okay, and really specifically, I mean the terminal side of the angle, because we already know where the initial side is if it's in standard position. It's on the positive x-axis. So I've already given us a little refresher here for our quadrants. You can see we have 1, 2, 3, 4. Okay, but the one thing I want you to notice is angles in standard position. If you remember, they start at the positive x-axis, and we rotate, for positive angles at least, we rotate counterclockwise. So if you start at the positive x-axis and start rotating counterclockwise, you'll count the quadrants in order. 1, 2, 3, 4. Now that we've said that, the way that we would describe this angle that we have here is we would say that it lies in the 4th quadrant. Okay. Let's say, let's call this one phi. So phi lies in quadrant 4. Okay. Now we're going to look at our first way that we are going to measure angles, and that is in degrees. And most of you are already familiar with this. Okay. Right? We have 360 degrees in 1 revolution. Or if we wanted to word this in a slightly different way, we could say that 1 degree is 1/360th of a complete rotation or revolution. We are going to actually spend some time looking at another way to measure angles, which we'll call radians, and we'll learn about that here pretty quick. All right, another refresher from high school geometry, just the definitions: acute, right, obtuse. And so I already sketched these in here because I'm pretty slow at drawing in these angles here. Okay, but the acute one, you can see in the picture here, it is an angle that is between 0 and 90, like you expect. And the right angle just means that it's a 90-degree angle. And then obtuse, this is if we're between 90 and 180. All right, next definition here: an angle whose vertex is at the center of a circle is called a central angle. Okay, And actually, with the way that we are going to define our trig functions, we're going to be working with central angles a lot in here. Okay. And in fact, we're going to need this definition anyway to learn what a radian is. And again, a radian is just some other way that we can measure angles. Okay. So let's actually get an idea of what a radian is. Okay. So let's maybe read it first, and then we'll try and use the pictures to help us interpret what it says. It says another way to measure angles is in radians. 1 radian is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. Okay, so let's try and unpack that. So we have a radius of r. Okay, and so is what this is saying is 1 radian is equivalent to sweeping out an arc on this circle that's equivalent to the radius. Okay. And if it were 2 radians, it would sweep out an arc along this circle of length 2r, 2 times the radius. And if it were 3 radians, then we'd sweep out an arc of length 3r,